This is section 12.3, and we're learning about the factored form of a quadratic function. If you look down at the bottom of your note sheet, we have a little summary of the kinds of forms of quadratic equations that we have. We already know about the two forms of quadratic equations we already know about are the standard form and the vertex form. The standard form of a quadratic equation is y equals ax squared plus bx plus c. And from that one, we know it's easy to use the quadratic formula when we want to. It's also easy to recognize what the y-intercept is. If we think about letting x be 0, then the y-intercept is what you have left when x is 0. So if this was 0 and this was 0, if x was 0, both of those terms would be 0. All that would be left would be the c. So the c is your y-intercept. So points easily found are the y-intercept and the y-intercept is just x is 0, y is c. So in terms of what we know on a graph, if we were to graph our parabola, oops, didn't want that. If we were to graph our parabola, then what we do know from the graph is this point right here where it hits the y-axis is c. That's the point 0c. So that's what standard form gives us. That's the most basic information we can get from that equation. All right, the other day in section 12.1, we also learned about the vertex form. And in 12.2, we learned how to put a standard equation into vertex form so that we can easily find the vertex. So the vertex form is y minus k is equal to a times x minus h, the quantity squared. And what we know from that, the point that's easily found, is the vertex. That's why we call it the vertex form. So the vertex, when we have an equation in that form, is just h k. The number subtracted from the x is the x-coordinate of the vertex. The number subtracted from the y is the y-coordinate. So when we look at a graph for that one, what we know is that this point right here at the bottom is the vertex hk. Or it could be that your parabola is upside down, in which case your hk is the maximum, the peak. All right, so now we're going to learn about a different form. So the new form of the equation that we're going to be talking about is the factored form of a quadratic function. And it's just what it sounds like. It's the factoring that we did before, where you have two binomials multiplied by each other, like this, right here. But before we actually talk about what that means in terms of the quadratic function and what it gives us, we're going to learn about the zero product property. We've actually talked about this a little bit. If you have two numbers that multiplied together give you 0, then in order for the product to equal 0, either a equals 0 or b equals 0, or potentially both could equal 0. So in order to solve a quadratic equation that's in factored form, what we do is we set each of the factors equal to 0. So either this one's equal to 0, so 0 times something equals 0, or the x minus 4 equals 0. So we take those two equations and we set them up and solve. So x plus 3 equals 0, so x equals negative 3. That's one solution. Or we have x minus 4 equals 0. And if we solve that, we get x equals 4. And that's our other solution. So how this is useful to us in terms of a quadratic equation and knowing something about the graph is if we have an equation that's in factored form, such as this one here, if we want to know what the x-intercepts are, the x-intercepts are when y equals 0. So you're actually solving an equation, 0 is equal to a times x minus r sub 1. You don't need to write this part down. Times x minus r sub 2. And if we solve each of those separate factors being equal to 0, we're not going to worry about the a because it's just a number. It's never equal to 0. But x minus r1 equals 0 means x is equal to r sub 1. That becomes one of our intercepts. If we solve x minus r sub 2 equal to 0, then x equals r sub 2. And that becomes our other x-intercept. So what we want to do is finish our sentence here on our notes, and what we're going to say is that the x-intercepts of the graph of y equals a times the quantity x minus r1 times the quantity x minus r2 are r sub 1 comma 0 and r2 comma 0. So what that means is when you solve those two separate factors being equal to 0, what they tell you are the zeros or the x-intercepts of the graph. In terms of vocabulary, write this down. We have three different terms for the zeros. Sometimes we call them zeros, which is places where the y value is 0. Sometimes we call them x-intercepts, because if y is 0, then your point is on the x-axis. And the other thing that we call them is roots. So now let's look at example 2. So it says, consider the equation y equals x minus 1 times x plus 5. We want to find the x-intercepts. So in other words, what we want to do is figure out when is y equal to 0. Well, if this is equal to 0, then we want to set each factor, x minus 1 equal to 0, or x plus 5 equals 0. This gives me x equals 1, and the other equation gives me x equals negative 5. So those are my two x-intercepts on my graph. So I know that negative 1, 2, 3, 4, here's negative 5. That's an x-intercept. And here's 1. That's an x-intercept. So I know my parabola is going to pass through those 2 points. The fact that there's no negative in front of the x minus 1 means this parabola is going to be opening up. I know that much. If there was a negative, it would open down. I also can find the vertex really easily now because I know it has to be halfway between these 2 points, which you could just graph or look on the graph and find the halfway point, or you can actually average the numbers to find the x-coordinate of the vertex. Take negative 5 plus 1, divide it by 2. That's negative 4 divided by 2. So the x-coordinate is going to be at negative 2. So we know that our vertex is somewhere along there. That's our axis of symmetry right there. Right? So to find the y, we just take this negative 2 and we plug it back into the y equation. So y equals negative 2 minus 1 times negative 2 plus 5. Negative 2 minus 1 is a negative 3 times negative 2 plus 5 is positive 3. So I know my vertex is at negative 9. Probably I better adjust my scale on this axis. This one we had a scale of 1, but on the y-axis we might want to go with a scale of 2. So negative 2, negative 4, negative 6 down here would be negative 10. So my y, or my vertex, would be right about here. If we were to put our equation into standard form by taking our y equals x minus 1 times x plus 5 and foiling it, if we put it in standard form, then we could know the y-intercept, we'd know another point and its reflection image, and we'd have a pretty good idea of the graph of this parabola. So first, outside would be 5x, inside would be minus 1x, and last would be minus 5. So we have x squared plus 4x minus 5, and those numbers tell us, at least the last one tells us our y-intercept is negative 5. So since we used a scale of 2, that would put our y-intercept right here. We have the reflection image of that point on the other side of our axis of symmetry, and so between those 5 points we can get a pretty good idea of what our parabola looks like. So we're just going to connect the points with a smooth curve, and we get something like that. If we wanted a little more accuracy, we could find some more points, but that gives us a pretty good idea. All right, so that is section 12.3, and it's talking about the factored form of quadratic functions. Key idea is when it's in factored form, then you know that the opposites of those numbers actually are the roots of your equation, which translates into them being your x-intercepts. Not negative 1 and 5, but they're opposites, 1 and negative 5.